expressed on this radio station, its programs, and its website by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and freedomslips.com, its staff, or affiliates. You're listening to Revolution Radio, freedomslips.com, 100% listener-supported radio, and now we return you to your host.
Ladies and gentlemen, we are back with another episode of Cosmic Catastrophe on Revolution.radio. I'm your host, Diamond from the Oppenheimer Ranch Project. Joining us today is my lovely co-host, Leah Shaper.
Hello.
And many of you know him. He fills in for us often when we cannot do the show. Ransom Godwin from Mountain High Time, 420 TV. Are you there? Your mic is muted. I've got no audio from you.
Yeah, that's weird. His mic is on. I can see it.
Yep, it says it's muted on my side, so try to figure that out. We got a great show while Ransom figures out his microphone. We're going to be talking about the consequences of a magnetic excursion. The first article that I'm going to pull up here says, well, let me read it for you directly. Could Doomsday come from a reversal of the magnetic poles? Now, do you got your, is your mic working?
I think so.
Yeah,
There
you're
we
back.
go.
Good to hear you. All right, so we're going to be discussing. Now, before we jump into some of the articles, we've been talking about this for years. We've done multiple shows on the topic. We've talked about we've hit it from every different angle. But let's talk about the humanitarian aspect here. This ongoing event that we're all living through right now, the reduction in field strength of the Earth, is a magnetic excursion. And therefore, it is the most consequential thing occurring right now on our planet to our species and to all of humanity. And why it's not front page news every day has everything to do with the control narrative of world governments and the fact that entire society panicking is not a really good way to run the Earth. So they just keep us in the dark. Now, what are your thoughts? First of all, do you guys agree with what I just said? And what are your thoughts on why almost no one in the general public knows what I just said?
I think it's because they don't want them to know. No one would act accordingly if they knew. The paper I just read, I hate to say it, but the lighter skinned folks are in trouble.
Well, the other thing here, too, is that obviously we have a global elite that is very invested in scaring the crap out of the public with a global climate change hoax. But that's only because with that, you can use that to guilt trip people and make them afraid and then cause them to do things. For something like a magnetic reversal, what are you going to do? Tell people to change their personal electric charge? You can't really talk anybody into doing anything and thereby controlling them with this. So you might as well just not bother mentioning it.
But if we pay more in carbon taxes, I'm sure they'll come up with a solution to save us.
Right.
Yeah, the big issue, and we've all alluded to it, is the fact that if they were to come clean and people were to scream this from the rooftops, that the society that we live in would come to a halt. People would stop going to their jobs and providing for their family, and they would focus on prepping for something that may be inevitable in their lifetime. And what I mean by that is this is not like the magnetic excursion. Even if it's a magnetic reversal, it doesn't happen in a day. It's over a period of time. It's much more rapid than we initially thought decades ago. These reversals, and we're going to get to the Laschamps specifically. We'll talk about the data there. Recently, they uncovered a kauri tree, an ancient type of tree that literally lived for the entire time span of the Laschamps magnetic excursion. And it shows that in the initial stages, the field dropped rapidly in just 240 years to 6% of the field strength currently. That would be devastating to all life on Earth, and we'll explain why in a bit. So the first 240 years was rapid down, and then it took about 600 years or a little less to come back. So the whole thing is less than 1,000 years. The largest magnetic excursion since the last reversal, basically, the Laschamps, which also coincided with the mass extinction. And that all happened within around 800 years. And the drop down was 240 years. And we have been dropping down for several hundred years. So, and it's increasing. So you do the maths. What are your thoughts?
Not a linear development. So just by virtue of the fact that it's exponential, the rate of change of the magnetic field, that definitely puts us potentially into some trouble here.
Mr. Godwin?
I was just thinking, if it's been ongoing for a couple hundred years, we should be expecting the peak in the next couple hundred years, followed by another couple hundred years of that. You said about 800, I think I read also, right? That the entire thing happened, which is really fast, right? For as far as evolutionary terms, that's nothing.
I mean, in reality, the Laschamps, the reversal part of the Laschamps lasted for about 800 years. But the decline in magnetic field, the rapid part was about 240 years. But to be fair, there was a long period of decline before that.
Yeah, and that's what we have been experiencing, a long period of decline, probably for several hundred years. And around 1859, during the Carrington event, a geomagnetic jerk occurred on Earth due to the solar storm that was blasted at us, the largest solar storm in modern history. And then the field strength changed trajectory from slow depletion. At that flexure point, it began rapidly reducing at an exponential rate, as if it was falling off a logarithmic cliff. And if we extend the line forward, it culminates in zero field strength in sometime around 2045. That's not that far away. And if, in fact, we approach zero field strength, let's say in 2035, that's not a lot of time from now. That's 11 years from now. We could be in a Laschamps type excursion. And so what does that mean? What are the consequences? Well, until recently, most people poo-pooed it. They said there were no consequences. The reason why is they did a cursory review of ice core data. And when they looked at the ice core data, they didn't see anything environmentally catastrophic. The polar regions were still cold. All they found was a beryllium spike. So they're like, well, that could be anything. That could be a supernova. That could be a solar storm. Nothing impressive there. So they really didn't dwell on it. The problem is the biological effects are most severe equatorially and in the lower latitudes where everyone's living now. And we don't have any ice core data there. So the data set was limited until we started finding lake deposits that went through these excursions and uncovered the Kari tree that was perfectly preserved that during the Laschamps magnetic excursion. And we developed paleontological records which showed mass extinctions now corresponding to these reversals. So what's going on? If there's nothing impacting the Earth, so how does a magnetic field kill stuff? That's the big question.
Well, and the other thing about, the ice core records for this period of time, you get like you said, we get the beryllium spike, we get the carbon-14 spike, but, one of the climate effects apparently was the expansion of the ice sheets, like the Laurentide ice sheets, which is not really going to be reflected in the Greenland ice core so much because it's already icy and cold there, So like you said, without this other data from other parts of the planet, the climactic changes aren't going to be so obvious.
Yeah, and what's happening here as the field reduces, our magnetosphere reduces. The magnetosphere is the protective sheath on Earth that's protecting us from cosmic radiation. So we get this high influx of radiation from space and ionizing particles, literally like being in a microwave oven. Mm-hmm. But it's like microwave oven light. So you actually won't heat up like your morning coffee or your leftovers, but there's still radiation going through your body. There's going to be cell damage if you go out during the day. And the biggest biosphere killer is the complete destruction of the ozone. So the ozone, remember the ozone scare because of chlorofluorocarbons? And then it miraculously healed itself.
Because of all of that hairspray we were using?
That was it. It was because of Aquanet. You used to use that, Ransom, right?
No, I never did that. But, you know, this whole concept has put a lot of pieces together to me and as far as anthropology. And, you know, I've been studying my own genetics. And when I look at the genes that I've carried over from Neanderthal, this whole thing makes complete sense. The whole idea of UV radiation burning down. So I'm thinking that Neanderthal was not the only light-skinned hominid running around. So he wasn't the only one that was having problems at this time, which might explain why there was a massive amount of movement, mixing, and all kinds of other things as a necessity.
Yeah. Okay.
I mean, I think we'll get into this later, but it's really interesting to me that not only do we have the extinction of the Neanderthals at 42,000 years ago, right at basically the high point of this reversal, but we also have anatomically modern humans moving into Europe shortly before that, and also. We'll talk about this later, but there's the ghost DNA species, which it appears that most of the interbreeding with that species was around 43,000 years ago. So it looks like there are these environmental changes that are happening that are causing hominids to move, and maybe also, you know, losing some population is encouraging interbreeding as well. Diamond, you're muted.
Yeah. Well, I also think that these excursions coinciding with this influx of radiation is not only bad, but it's also good. Let's take, for instance, the Renaissance. The Renaissance was a time of low solar activity, high cosmic radiation, and people somehow became smarter. They wrote, I mean, what happened? We all went inside. It's cold out. There's not a lot to eat, and we all become brilliant composers, and we make Stradivarius violins. So there's some connection with cosmic radiation and smartness.
Well, we also become amazing cave painters too.
Yeah, and this is also happening at the same time of the largest spike in cosmic radiation. We get not only the first cave painting, we get the first intricate carving, the Lion Man. So something happened here. I don't think people just went in a cave and ate a bunch of mushrooms. Something physiologically was happening with hominids. And just like Ransom said, and you said, there was a huge orgy happening beginning around 4, as we were dipping into this excursion. All of a sudden, all of these hominid species started intermingling.
Mm-hmm.
What's going on? It could have to do with the fact that their populations were being reduced and they didn't have any other recourse, or something else was occurring. Hominid species were coming smarter, if I can say that in the simplest terms. And they knew, I mean, we know that our best chance of survival is through breeding children. Mm-hmm. And the more diversity your genetics are, the better off your offspring is going to be, because they're going to have more traits that may be beneficial in a future environment. That's basically the explanation of evolution.
There might also be a psychological factor in the sense that, you know, when your life is directly threatened in the present, I mean, you have a tendency to live more in the present, which in my opinion is kind of a more inspiring way to live. Like there's something that happens, I think, in the human brain sometimes when you're kind of on your toes all of the time, if that makes sense.
Well, yes. That's true. So at this time, what's happening is that the whole world is changing to these hominids. They're seeing aurora like they never saw before. It would be terrifying for them. They wouldn't know what's happening. So you've got this global terrifying phenomenon that's passed on generation to generation, and it keeps getting worse. So you're teaching your future generations about the changes, and then they see it getting worse. It's almost like a period of thousands of years where hominids are living in unknown territory or fear, perhaps.
Mm-hmm.
Anybody?
Yeah, I was thinking about that a lot, and you know, not just going into caves, but most likely you were going into caves with other species. So this is when they were communicating, and this might have been the reason we started drawing things, depictions, trying to communicate with someone that may have not had the same speech as us, but could look at visual stuff. But not only that, the things that were contributed by the other species is the reason that our core species is still here today.
Mm-hmm.
In other words, like if there were a bunch of guys walking around that say they have really light skin for whatever reason, that's just what their group was, and then the older population started coming up with you know, skin cancer, things like that. The women are probably not going to want to so much mate with people that look like they have diseases. Um, I mean, I'm just saying. So it would be encouraged. And not only that, when you study Neanderthal, they had a backwards way of gene transfer than say humans do, as far as they sent the women out. The women are the ones that traveled. So that makes sense why there's no Y chromosome coming from Neanderthal. And not only that, you would have had the other modern humans out there, and that's who they would have met, was women, and then they would have been contributing. And a lot of people think that the hominid species were like one color, another color, and most likely all of them had a range of colors. Like Neanderthal went from dark brown all the way to light, and they know the gene specifically that causes that. And a lot of us have inherited those genes. Like I have the dark gene from Neanderthal. And right, there's another gene there that talks about, and this is weird. It says that I'm not likely to have tan, and I have an increased, you know, incidence of childhood sunburns, which I didn't have actually, but that may be because I have the other gene that um, gives dark skin pigment that would have that protects me. I mean, basically, and not only that, I going through that paper, I guess they were insinuating that literally the darker the skin is, the more removal of damaged DNA that there is.
Mm-hmm.
Plus, there's the problem, you know, once you go black, you never go back. You're not supposed to be muted. We're supposed to get your laugh. All right. So previous studies on this topic of magnetic excursion found very little in the way of environmental impact. But that conclusion was based primarily on ice cores, as we alluded to early on in the show here. And then they found the Kauri tree. This is Cooper and his colleagues. They conclude that the magnetic reversal was in fact related to the extinction of a large fraction of large animals at the time, as well as the disappearance of Neanderthal, and like we said, the appearance of cave art. So cave art really comes in a big way around 40,000 years ago. This is after the event, about 1,000 years after. But 2 years ago, in Indonesia, they found a painting that they dated to 45,005. Appears to be the beginning of it. And that's at the very beginning of the excursion. So as it's beginning to happen, the painting begins and it continues throughout the entirety of the excursion. And like you said, Ransom, because we're co-mingling in caves during the day. Because when Uncle Bob and Jimmy go out to hunt during the day, they come back with big welts on their skin and they die in a month. And so people stop hunting in the middle of the day.
You know, it's also worth noting, and it's not this painting in this image here, but there's a 42,000-year-old cave painting from somewhere in Spain that has, you know, similar handprints, and they're in red. And it could very well be that red, or maybe it probably is, because this would be easy to determine, is probably red ochre, which can be used as a sun protectant, right? Even some animals use it. No, I'm sorry. I'm thinking of the hippo. There's a hippo that sweats red that provides sun protection. But human beings obviously have known about this for a long, long time. And it would make sense that this would be the time period in which we would discover the use of red ochre for sun protection.
Absolutely.
Yeah. And the Clovis time period as well, which is becoming extinct, they say, after a magnetic excursion and a catastrophe that we know of called the Younger Dryas event. Those were the red ochre people.
Yeah.
These are people that were buried, covered in the ochre, and there is evidence that they used it on their skin. So the red ochre people, there has to be a reason why they were rubbing this on their skin. And it's definitely, I mean, Occam's razor, protection from the sun.
Well, and plus it would be easy to figure that out. Let's say, like, you know, based on certain animals that have that capability to produce a red pigment that protects them.
Yeah,
So
and it's
go ahead.
weird how they thought it might have protected maybe people in the afterlife as well.
Yeah.
Yeah, isn't that's a great idea. If it protects you on Earth, it's got to protect you after you die. Jeez. All right, so there are major consequences to these excursions, and they will slowly ramp up as the field weakens. It's happening now. It's been ongoing since we were all born, and it will continue to weaken until we die unless it flips. But there is no evidence that this field is going to strengthen anytime soon.
Well, and as a very light-skinned person myself, I can definitely attest to the fact that over the course of my lifetime, it has become certainly easier for me to burn. Now, it doesn't take a whole lot, but, you know, it takes less than it used to these days.
And the sun is definitely hotter on the skin than it used to be 40 years ago.
Yeah.
Anyone that drives a car that's old enough can attest to it, that it's unbearable sometimes to have your window down if the sun is blasting your arm.
Mm-hmm.
Right. You know, I was just wondering though, you know, that paper you sent me, it sounds like sunburn is a necessary component in health, or tanning. Like, it gets into the removal of these damaged DNA. So it seems like periodically, no matter what tone you have, a sunburn might be a good idea if it's not extreme,
Yeah.
just to kick in your immune system to get rid of these dead cells and damaged DNA strands.
Yeah, no,
And
that paper makes it clear that the processes going on for both tanning and sunburn are actually fairly similar to a degree, right? Provided that the sunburn isn't isn't very extreme. But in both cases, there's ups and downs to the tanning and the sunburn, right? It's kind of a mixed bag as far as the benefits and
even
damages.
dark skin humans, they tan as well, even though it might not be noticeable.
Yeah.
So there is some kind of biological necessity, as Ransom said, to having exposure to the sun. And we know this from COVID. People that are out in the sun every day didn't get sick. People that are in the sun have vitamin K in their body and they're getting the correct amount of vitamin D. It brings your immune system into stasis, homeostasis, which means you're in perfect condition to fight off anything coming at you and you don't get sick. Which is exactly why the CDC and everyone else told us to stay inside, because they were trying to create a pandemic. I just got us demonetized. Look at that.
You wouldn't want to have adequate levels of vitamin D, for God's sake.
This actually insinuates a lot. Like, you know, that paper that shows what Neanderthal genes I'm positive for. One of those is the night owl idea, that I'm predisposed to be awake at night, which if you think about that and then you go back to this time period, that would have been essential. Not only tanning, being able to tan or turn brown, but people were staying up all night. Why were they doing that? I mean, and that's the genes that got passed down to us, were the beneficial ones, but also we got passed down the susceptibility to diseases that the other groups wouldn't have had. So it's like you said, it's a mixed bag. We got good things and bad things from these transitions of mixings.
That's a funny way to think about it. During these excursions, the whole world starts working third shift.
Yeah, right.
And so we're sleeping during the day. So let's talk about the specificity of the Laschamps excursion. It took 240 years for the polar reversal to occur, with the magnetic field strength dropping to 6% of present-day strength during the transition, while the magnetic North Pole wandered south to New York and then west to Oregon. So the North Pole at this time went down to New York and then moved across the U.S. over to Oregon. Pretty bizarre. Then the pole zipped south to Antarctica, and this would have been a full Earth polar reversal, where it's a true reversal, but it snapped back, so it doesn't count. but it stayed in Antarctica. The North Pole was in Antarctica for 400 years. And as it was down there, the field strength came back a little, came back to 28% of full intensity, but the excursion was still ongoing. And instead of having a polar flip, the North Pole left Antarctica and zoomed back up into the Arctic. Isn't
I
that
thought the reversal was actually 800 years, but does that include the period of time where the pole is like in New York and Oregon?
Yeah, that's the whole thing.
Okay. I mean, because it's strange to me that we still call this an excursion, even though we had a polar reversal for 800 years. But I suppose it has something to do with the fact that it's actually moving around. And also 800 years in the span of geological time is really instantaneous.
Right. What tends to happen with polar reversals is that the field stays that way for extended periods of time. Because this flips so quickly, it's not considered that.
Right.
Just a geomagnetic excursion.
Right.
Which means the poles could flip during this excursion for a period of time.
Yeah.
Well, not only that, they've done some reconstructions of the Laschamps. At the time when the North Pole is in New York and moves over to Oregon, there are multiple poles on Earth because the field is so weak. There are like multiple North Poles, different, very low energy norths and souths. And it would be chaotic for all animals that use the magnetic field for migratory and for feeding purposes. It would be a really strange Earth.
Mm-hmm.
That's exactly what I was going to ask you. It's like you're reading my mind. I was wondering if there's any papers associated with like sea life and other animals that decreased in populations at the same time, that are more animals that are based on magnetic migration, like whales, birds, etc. Do you think that, I mean, is there any evidence of that? Because you mentioned the tree, which is a good example of what's absolutely going on. But is there other, like papers out there about dwindling sea life or birds or things like that at this time? Is a question. I'm sorry.
Well, there is a paper, and I'm pretty sure you know it, The Role of Geomagnetic Field Intensity in Late Quaternary Evolution of Humans and Large Mammals. And they show a whole grouping of large mammals, and their extinctions coincide with low field strengths. So things like mastodons, and that might have to do with their feeding patterns, or the fact that maybe the grasses where they're growing now are fried by the sun and they don't even grow there anymore. So they're simply starving. I don't know if it was so much exposure to the radiation, although the big mammals, they don't live in caves. They just stand in the middle of a field. So they're the most susceptible to mutations and actually dying from exposure. So that might be the main reason. Ocean creatures typically fare amazingly well during excursions because radiation does not penetrate through the ocean. And even when impacts happen on Earth, think about it. You could have these catastrophic winds and heat, not going to happen right under the ocean water.
Well, I meant more like the instinctual magnetic migration of them, like beached whales and things like that, like where they traditionally go. You think that would have been in total havoc at this during this period?
Yeah, we should do a... Go ahead.
It probably was. I mean, there's so many different ways in which an animal can be at risk in this environment, right? There's the direct radiation exposure and genetic damage. Then you've got the effect on migratory patterns, the animals that are reliant upon field strength in order to navigate and find their food. Then you've got, climactic changes that appear to be in the works here. I mean, there's so many different reasons why any particular animal could really drop population numbers. It may just be if assuming that the research isn't there, and I'm just assuming it's not there because we haven't found it. For some of these species, it may just be an issue of the amount of work that it would take to, let's say, follow one particular species through this, finding enough fossils to really accumulate enough data to determine whether or not those animals were affected by low field strength.
And what you can see here on this study in this green portion of the graph is the number of extinct species. And it slowly rises up to a peak, the peak here coinciding exactly with the Laschamps reversal at 41,500, and then it slowly ramps back down. So the extinction time frame is the entire reversal, the drop down and the recovery, which is interesting. But it's most extinctions happening right here at the lowest field strength, right here.
Well, and then look too at like this dung fungi influx rate, right? The changes in that, even just of microorganisms, always affect the entire food chain, right? So that's going to make a big difference too.
Yeah, and they seem to just come to a halt here.
Yeah.
Right at the excursion.
Yeah.
Wow. Crispy.
Yeah, so let's talk a little more specifics here. They analyzed the Cori tree samples and they confirmed a pronounced surge in cosmogenic isotope levels during the transition. Additional data revealed a modest depletion of the ozone layer, a slight increase in ultraviolet radiation, especially near the equator, and an upward shift in tissue-damaging ionizing radiation. That sounds like a great vacation.
Mm-hmm.
So do you think this this same mechanism that would cause, I mean, I know you've talked about it before, but this would be the same mechanism that causes speciation, whether directly or indirectly, right? Like, so some species mutate, others just die out, and then that opens up niches for other things to expand out, would cause rapid influx of new kinds of animals right afterwards, right?
Yeah, well, and we've talked too about like, the idea of panspermia, that a lot of the genetic material that is unearthed potentially has actually come from outer space, because there's actually quite a lot of data showing that the amount of the survival that's possible in outer space is kind of extraordinary. But so ostensibly you could say that, maybe once the conditions change, then you end up with certain conditions that happen to be right for that particular genetic material to like actually take hold and manifest.
Right.
Yeah, so the problem now that we have today is the effects are going to begin much earlier than they did back in historic times, back when early hominids were here. We live in a technological world that's connected by wires, computers, and infrastructure that's all powered by low Earth orbiting satellites to the tune of tens of thousands. And then there's hundreds of thousands of decommissioned satellites flying around up there. It's literally a space junk nightmare about to happen. Because as the field weakens, we're going to continue to have solar cycles, and we're going to continue to have solar storms. And the weaker the field, eventually the party that we call the modern world is going to come to an end. And that's another threat that we're not being told about.
Right. Well, and not only that, it's all of that modern infrastructure that makes it possible for human beings to live in places on Earth that we otherwise wouldn't really live, right? So when that comes to a halt, that's another level of ridiculous, right? Like, people who are living in like Phoenix or something. I mean, it's just ridiculously hot down there. You wouldn't live there if you didn't have air conditioning. Well, that's going to come to an end.
Right. I read somewhere, I think that this was the same paper, that during this time there was a lot more electrical activity, which in my mind means a lot more fires, which means a lot more migration also. And you think about that in modern terms, we see the devastation that happens anytime a lightning hits something, and then the whole area burns up, and then follow that by lots of floods. Like, I'm sure you guys were paying attention to the Ruidoso thing. Last night, they had mass evacuations again. They were telling everybody, forget your house, forget everything, just leave because it's going to flood. And that would have been happening back then also. So people would have been having to bug out and get away from areas, large amounts of fires, flooding. The whole thing would have just seems like a nightmare. And trying to imagine that scenario in today's world is like 10 times the nightmare.
Yeah, the lightning issue is huge. So not only have we seen in our lifetime the frequency of lightning increasing, it's one of the predictions of what happens during these excursions. The lightning gets not only more frequent, but it gets higher charge. So there will be a point where lightning bolts are 10 times thicker and stronger than they are currently, and they'll be happening at a rate of 1,000 times more often.
Wow.
So another reason to live in caves.
Yeah, and you would never go out in a thunderstorm. You would immediately explode from lightning, and people would be witnessing like their friends exploding from these lightning bolts, and they would run to the cave and they'd stay there.
Well, not to mention, I know you guys have seen like an entire herd of an animal just dead from one little lightning bolt. You imagine coming across a field and everything's dead. That would make me want to move. I'm out of here. I'm sorry, man.
Yeah, that just happened in Colorado, right? It was like 20 or 30 cows and a farmer.
Right.
And that was one bolt.
Right. Like everybody is acting as a conductor, and that's it. Makes you want to get away from other people when you're in a thunderstorm too.
My cave, get out.
Get away from me.
So let's stay on the same topic, but talk about it in a broader sense. Because a lot of people on the internets, because everything is true on the internets, a lot of people are claiming that these events are periodic, specific, in a very specific way. They happen every 6,000, 12,000 years, like a clock. Now, we do have a clock cycle. It's called the Great Year, and it describes the precession of the equinoxes, which may or may not be the wobbling of the Earth around 26,000 years. It's my supposition that we are moving in a Birkeland current, and we go in one circle every 26,000 years, which would be the precession of the equinoxes, and that the pole of the Earth is fixed. It's not wobbling. It's only wobbling in the minds of people that believe in gravity and accretion, and all that gobbledygook is nonsense, because the Earth and every planet would eventually get sucked into the sun, and that doesn't happen. Our orbit is constant and specific. And so it's more like an electron in an orbital of an atom. That's our solar system, rather than this stupid accretionary. It doesn't work. The standard model of what they're telling us doesn't work. And you can prove it, because in order for us to have gotten to the moon, the initial calculation was close enough to get there, but they had to recalculate the trajectory every hour, or we would have missed it by 1 million miles, all the way up to the last few seconds of landing on the moon. They had to constantly recalculate the trajectory, because we really don't understand what's going on in our solar system.
Mm-hmm.
That's why they're trying to put a clock up there on the moon.
Yeah. And so this paper just came out from the Russian Journal of Earth Sciences, and it uses advanced math, unfortunately. They use multi-pole moments. So we'll leave you links to this paper if you want to try to understand the math they're using. But the whole point I want to get to here is that they have a different data set of the field strength that I've never seen before. And this is from observations. And so the Russians have a field strength data set here. The key we want to look at is the red, and that would be the field strength data. And you can see the line here, 2, that's the Laschamps magnetic excursion, which is the highest peak in red, corresponding to the weakest field strength in the last 100,000 years. Mm-hmm. Is everybody following me?
Yes. So I have a question. There's only 2 major low dips on there. One is at before that excursion, and the other one seems to be right now, right? Is 0 now?
Yeah. We're going back into an excursion now.
Okay. That's what it looked like.
And right. And so there was something also going on. Look at this, Leah. This is like the bowling Alarod.
Yeah. Yeah.
And then this, so this is the bowling Alarod and the Younger Dryas event.
Yep.
And 60,000 years ago, we do have that excursion. It's the Blake. Do we have it named here?
I can't remember what it is.
Right
is
here.
It Blake?
It's the Laschamps and then the Blake.
Well, and the Laschamps is on that graph too.
Yeah.
Well, and the other thing is that, well, when we get back to that graph, the green line is essentially would be like a more descriptive mathematical expression of the magnetic field strength. So it's worth looking at the changes in that as well. But you kind of see an overall similar pattern in a way.
Yeah, and the problem is that the main so here's the problem. We don't know what generates the magnetic field of Earth.
Right.
And as when you start writing these papers about what's happening and you don't know what's happening, that makes zero sense.
Well,
how do you come up with the conclusion if you don't even know what's generating the magnetic field?
That's one of the problems with this paper, because this paper does presume what exactly is causing the magnetic field and its changes. But at the same time, it's literally just using a mathematical expression of the field strength to show when reversals would happen. So it almost doesn't matter. You can kind of just discount their causation explanation.
Yeah, they get so specific, it unravels the legitimacy of the paper. They start talking about the inner dynamo, the liquid inner outer core, heat transfer through the mantle, and you're like, all of those, you just made that up.
Well, they're claiming that their math lines up with those descriptions, and I don't think that you can really make that claim. The other problem with this paper is I think there's kind of a translation issue in here as well.
Yeah,
it's very hard to read because of the way some of the sentences are structured, and some of the vocabulary being used.
The conclusion I wanted to show is that what they found based on observations and running it through their multi-pole expansion models shows that the period of oscillation in the magnetic field can vary from 8 to 10,000 years all the way to 20 to 30,000 years, which means there is no 12,000 year cycle. There is no 6,000 year cycle. And any graph that we look at that shows the magnetic field strength proves that there is no recurring cycle of magnetic excursions. Mm-hmm. Would everyone here agree?
Yeah, it's too random to be a cycle.
Yeah.
Well,
but what it is exactly what I studied in college in stratigraphy. What we're looking at is a nested hierarchy of cycles. So there are multiple things affecting the field strength, and we don't know what they are, but they're probably related to the core of our Earth. They're probably related to the magnetic field because it's shifting. And geez, I wonder if they have something to do with that giant plasma ball in the sky.
Right. I mean, there may be a pattern, but it may be that the pattern is so large on the time scale that it's very hard for us to see. Because one of the things that paper brings to light is that, like you were talking about, there's nested cycles, but there's kind of nested cycles in the magnetic field. They talk about the dipole, the quadrupole, the octopole. Yep. But what they're saying is that when in each of those, when you hit the minimum, and the minimums of those dipole, quadrupole, octopole, when those coincide, that is when a reversal happens. So there could be a pattern. It could just be way too large for us to see, or it may actually be completely random. And it's certainly not 12,000 years.
Your thoughts, Ransom?
I was just wondering why kind of they base these papers still on the old model of what the core of the Earth might, like what they thought it was, when we have new scans that show that it's not even that shape at all, and that there's massive irregular shape in the core of the Earth. How could that, why would they still use the old model?
Well, the massive irregular shapes are in the mantle. There are low velocity zones in the mantle. We still have a solid inner core and a liquid outer core, but it's not there. The liquid outer core isn't a perfect concentric circle.
Simon, the output of your mic dropped suddenly. Maybe you could just move closer to your mic. It's hard to hear you.
Are you talking to me?
Yes.
My mic is. The volume went low.
Okay, yeah, that's better. Yeah.
Okay, so there is no pure mantle. We've got these low velocity zones that are emanating from the outer core that come all the way up towards the crust. And so it's not these perfect concentric rings like you alluded to, Ransom. It's something much different. But we do have something that appears to be solid in the inner core, spinning in a liquid outer core. And so that they still stick with that model. But what if the solid inner core is something more like a plasmoid, like a sun, that's being powered through the Birkeland currents that enter in the poles that produce the aurora? I mean, these are giant electric currents. when giant electric currents meet, they form a Z-pinch, and that would be happening in the center of our Earth, like a mini sun, the same thing as the sun, only in the center of the Earth.
Mm-hmm. And why not? Because we've postulated that there may be a progression of sun to, dwarf or gas giant, and then ultimately to a planet. So why shouldn't the structure of those things be similar? I mean, this is all just speculation, but
that's what we do.
So essentially, you're saying that basically all of the celestial objects are just at different time points in their life. They're the
right,
same
like
thing.
they're all in different phases of evolution, right?
Well, I don't know if it's definitely chronological. It's just different electrical states. So the whole supposition would be, let's say the Birkeland current didn't like our sun anymore, or it double coupled with Uranus, and Uranus turned on. We would then have two suns. If we had two suns, then all the planets would have to move into their new orbital shell. And this may be what happened. Saturn might have been much brighter recently, and we would have been in different orbital shells, and Saturn might have turned off, and then all of a sudden, all the planets rush by each other to get into their new current position that we're sitting in today.
Kind of like the realignment, like of magnetic flakes, whenever you change the magnet.
Exactly. And that the whole story of Velikovsky's story would coincide with the story we just told.
Or the better analogy might be even like if you just think about the chemistry of a compound being formed, of the atoms of two different elements coming together, and then as a result you have this whole shift in the electron structure.
Makes sense to me.
All right, we've got 9 minutes to wrap up the show.
Wow, that was fast.
I think we've covered a lot. When you look at the last 300,000 years here, we can see that in the last 45,000 years, we've had three officially named excursions. This one is officially named MD01-2444, followed by the Mono Lake and the Laschamps. And those are not on any regular periodicity. We've got the Younger Dryas event excursion. We've got an excursion about 34,500 years ago, and then 41.5. And then we've got the Blake 1 and 2, Iceland Basin, Pringle Falls 1 and 2, and the Portuguese Orphan. These are 40,000. There's no periodicity here. So there's no periodicity. All right.
Diamond, do you have the paper about the Laschamps excursion handy?
Which one?
The global environmental crisis 42,000 years ago? No? Okay, never mind. I was just going to ask you to pull it up because there's a really nice graph of...
Nope.
Okay.
Is it linked here? Is there a link I can get from?
Yes, there is. Scroll down a little bit.
Peer reviewed?
Published. Click on published, yeah.
There it is.
Awesome. So the figure, which figure is this? Figure 1. Yeah, this one. This is just awesome for this because, oh no, I'm sorry, it's not figure 1. It is figure 4.
Okay.
So this shows where we have anatomically modern humans arriving in Europe, right around 43,000 years ago. We've got the cave art that's picking up. And then you've got, and it's not on this graph, but from the article that Ransom sent about this ghost species of DNA that you find in African populations that we have not identified, that's 43,000 years ago as well. So it's right all at the same time. Like clearly the environmental and the extinction of Neanderthals at the end of this. So all at the same time, right as this excursion is really taking off, the conditions change, everybody starts moving, we start getting interbreeding, we have some extinctions. It's fascinating to see that all together on a graph.
And Ransom mentioned fires. Here they are. This is the onset of burning in Australia.
Yeah.
Right.
So the Aboriginals went into caves. That's where all the cave art is 40,000 years ago. There is 40,000 year cave art in Australia everywhere. Gee, I wonder why. If the
Yeah.
continent is on fire, where would you like to be?
Right.
Well,
and that's,
and
go
it
ahead.
tells you something too about how intense this process was, because all of these things start changing really before the reversal happens. So it's probably in that it's like in the 1,000 years before the reversal officially happens. So it's not even the 240 years where the field strength is dropping off dramatically. It's even prior to that. So it's very interesting.
Yeah, it seems like hominids were forced to critically think about what was going on because it didn't make sense for so long. Like if they're just doing their thing, they're making rock tools, they're just living their life, and then all of a sudden, there's lightning, fires, there's aurora, there's no humans showing up. I mean, this would have been pretty nuts. I mean, really, the whole 1,000-year period there.
Yeah, yeah. And I mean, that makes sense too in respect to the cave art, right? Like it's like you suggested, Ransom, that perhaps this is a communication device of sorts, but also like if you can imagine yourself living through a time like that, why wouldn't you want to record it in some way,
Right.
and make your presence known and say, I was here.
It could have even been like what majorly sparked humans to concentrate their efforts on paying attention to the sky and the cycle in it.
Yeah. And maybe also reproduction, right? Like if we're going to make it through this, we better make a lot of babies. And it doesn't matter if these are interspecies babies because this is who's available.
Yeah, they might not have had a choice at all. I mean,
Yeah.
if you think about that, if there's no women in your little group of people and then you come across women, well, you know what happens.
What's interesting is that early cave painting that they found in Indonesia that dates back to 45K is a extinct pig.
Right.
That's weird. Like, why would that be the first painting? An extinct
Right.
pig. Maybe it died off and you were sad. No more bacon and for breakfast, so you drew the pig.
Right.
Yeah, it's like when everybody freaked out about McDonald's not having their Szechuan sauce anymore. It's just a thing of the past. And they had to bring that McRib back because it went extinct, and then everybody freaked out until they brought it back.
McRib with the Szechuan sauce?
Yeah. I mean, if you think about that, if you came into a cave in 500 years and that's what you saw, some kind of weird sandwich on the wall, and they're debating, is it a UFO? What is it? It's a McRib.
With the Szechuan.
It's worth noting here too in this graphic that these changes are really happening as the carbon-14 level is really going up. So that tells you a lot about the weakening of the field at this point, at this juncture.
Oh, and that reminds me to bring up some myth busting here, the related topic. I continually get asked by people for some reason why the Earth was going backwards. It wasn't, obviously, the crust wasn't going backwards, but they believe that because they keep reading it. And then the other thing I keep getting asked, about this, isn't the poles going to flip? The planet's going to flip upside down. And I keep telling them, dude, that's flat Earth, man. And there's members all over the globe for that idea, but that doesn't make any sense. And then
no, right, because you're in
and
space, right? Like everything's just relative. There's no actual like up and down. Also, it's not a physical pole flip, it's a magnetic pole flip.
Exactly. So, and then the third one was part of the article you sent me down at the bottom, and I sent that back to you. They're worried about the carbon increasing. We got to get rid of the carbon to save us from this magnetic pole reversal. But I also read that carbon dioxide and oxygen and all of the other stuff in the atmosphere blocks most of the UV, a lot of it. So that doesn't make any sense whatsoever. We would want a lot more carbon dioxide in the atmosphere if we had this event.
Yes, indeed. So just like always, they're doing the opposite of what we should be doing.
Mm-hmm.
We should all be preparing for what is ahead. These excursions are bad as well as good for life on Earth, but it is the time as we approach it right now that's going to be bad for our modern culture. There's going to be a solar storm that affects the grid, that affects the satellites, and it's going to be a rocky ride. If you're not prepared for long-term power outages, if you don't know how to provide for your family, meaning hunt and fish and gather, you are going to starve to death.
And where do we find the red ochre, man? You're a geologist.
Hmm.
Like, where do I go out and just dig that up if my family's frying in the sun while we're looking for antelope?
Yeah, that does
I
seem
think
like a
you
good
could-
prep to have.
Yeah, red ochre, but I think you could probably just use some mud and water and just put it on your skin. The red looked cool.
Right.
Yeah.
No, I think there might actually be some specific properties of the red ochre that help scatter the UV, because there's a similar thing that's described by what
Well,
melanin
it would be
does
very
in
high
skin.
in iron. So it'd be an iron-rich clay that you're rubbing on. So maybe it's the iron, because iron easily oxidizes, it, rust, Fe3O2. So the iron being in there, if there's radiation coming, it would hit the iron.
Right, but it's going to scatter. It's going to scatter the wavelengths of light.
Yeah,
and
it's like-
maybe because of the iron. Yeah.
Like the armor of God. Check out Ransom Godwin. Subscribe to his channel, Mountain High Time 420 TV. The link will be below. And should they rewatch this?
Find us tonight
Yes.
at 8 p.m. Mountain Time on Magnetic Reversal News on YouTube.
And I'll replay it on Revolution Radio later.
Awesome. Support Revolution Radio and freedom of speech.
Listen to Revolution Radio at freedomslips.com, and we'll be right back after this message.